decomposition reactions? In a way, decomposition reactions are just opposite to that of combination reactions. Combination reactions are the first category of the reactions we have covered about, and that was what? When we join two smaller units and it forms a bigger one, that is of course known as combination. Opposite to that will be a decomposition reaction in which we supply heat, electricity or sunlight, and the bigger molecule gets broken down to its simpler components. Then we call it as decomposition. And how come this decomposition is a bit different from the digestion process we have read in biology? Digestion also happens the same way. The larger molecule gets broken down to the smaller one. For example, starch gets digested to glucose. The difference there is that there we are breaking down the large molecule to its smallest possible unit. Smallest possible unit. For example, if a particular necklace we have, and that necklace, एक हार है हमारे पास, एक necklace है that is actually made up of many beads, ढेर सारे मोतियों से बना हुआ है. And if you can break down that particular necklace with single bead itself, then that is digestion. Decomposition is that there is this bigger molecule and you are supplying one form of the energy or the other, and you are breaking it down to a simpler one. But that need not to be the smallest one. बड़ा मॉलिक्यूल को एनर्जी का फॉर्म लगा करके उसको तोड़ दिया. सबसे छोटे फॉर्म में तोड़ना जरूरी नहीं है, तोड़ दिया छोटे फॉर्म. This is decomposition. And in our textbook they have discussed about decomposition three various ways. The first one is it is dealt with the help of heat. The second one by the help of electricity, and the third one with the help of sunlight. In our examination, in board examination, at times they have given us 3 mark question that you are supposed to write down the equation based on decomposition by heat, decomposition by electricity, and decomposition by sunlight. Now in such cases what happens that at times we remember only the heat and we write all the 3 equations for heat thinking that we have completed the question. But there the marks will be cut of course, because they are clearly asked you to write down the decomposition for electricity as well as for sunlight. Clear? So according to the question, if the question is asking based only on thermal decomposition, that is the decomposition based on heat, then you are supposed to write down only those equations in which heat is involved. Clear? So we begin with, of course, decomposition by heat. And my request to the kids, try to join the class in time. But anyways, decomposition reaction. First of all, we are going to write down its definition. A single reactant breaks down when a single reactant breaks down to give simpler products. To give simpler products. Known as decomposition reaction. And of course, when decomposition reactions are carried out by heating, are carried out revealing they are known as thermal decomposition reaction. They are known as thermal decomposition reaction. And after this, we are going to deal with three various equations. The first one, whenever a decomposition reaction takes place, keep in mind one thing, that after the bigger molecule gets broken down to the smaller one, the first product formed will be its corresponding oxide. Remember that, always it happens so. For example, if you are heating calcium carbonate, calcium oxide will be formed. One of the product will be definitely that. Then remaining gases of course. Okay, if you are heating lead nitrate, again lead oxide. So first of all, an oxide will be formed and the remaining product will break down. Somewhere there is a uniformity in these reactions. Okay, so first reaction we are going to write out, that is of FeSO4. Definitely we are going to balance this also. And the second one is for the easiest most is calcium carbonate. Breaking down of calcium carbonate. And third one, of course, that is heating up of lead nitrate, PbNO3. This is almost like a favorite most equation in the examination. Lead nitrate. And of course, once we put the arrow mark, in many of the books you will find it as written as heat. And in some of the books you must have find it written it as delta. The triangle that also indicates heat. So we may use either of the symbols. We may write down heat or we may mention it in this way also. It's all the way same. It's all the way same. Oxide. Oxide I said. FeO3. First product will be an oxide. In this case, calcium oxide and of course lead oxide. Remaining of course gases. See the uniformity in these reactions. Okay. First of all, an oxide is formed and then SO2 and SO3 here. Where of course in gaseous state. NO2 and O2 here. These are in gaseous state. कहीं ना कहीं similarities have in the reactions. And these of course are in solid state. Of course we are heating also solid only. Solids only are heated up. Now let's balance these. And there we have for FeSO4 balances it all up here. And the second equation, CaCO3, this itself is balanced and we need not balance it again. Lead nitrate, PbNO3 whole-wise. How we remember it in how we basically can learn it, of course. You can balance it also, you have done balancing. But it's very simple to learn. We give this key to the student that lead nitrate का equation को लिखने के लिए ना, you remember 2 to the 4. This 2, this 2, this 4, and it is balanced. again have a look at these equations. The first one, of course, we are heating up ferrous sulfate. So end products, of course, we know pहला oxide बनेगा, then SO2 and SO3. Products याद हुए हमें. Then next one, of course, for calcium carbonate. Calcium carbonate gets broken down to calcium oxide and then CO2. Uniformity हमें समझ में आ रही है in all these. The first product, of course, will be its oxide. Okay, and the remaining one will be in the gaseous state. First one is in the oxide, that is solid, and the remaining one, of course, in the gaseous state. After that, once we go for balancing these, remember that the initially balancing for the first equation is very simple. Second one doesn't need any balancing. In third case, of course, you can go ahead balancing right from 2 balance करके अपने आप भी कर सकते हैं. लेकिन याद रखने का तरीका हम उनको बच्चों को बहुत अच्छे से समझा देते हैं. लेफ्ट एंड राइट वेट का जो फिजिक्स था उसमें पहला प्रोडक्ट ऑफ कोर्स रेड ऑक्साइड बनेगा and the second one was NO2 and O2, right? So हम कैसे balancing में लिख रहे थे, that was of course 2 and 2 and then 4 and got balanced, because in our examination we don't have much of a time to go ahead and keep wasting our time on balancing. Okay, so practice these equations so much that you have learned them by heart. Thermal decomposition. Here, note them down. You have 2 minutes of time. Noted? Everybody noted? Huh? Note kar liya bete? Let's move ahead for the next one now. The next one, of course, is breaking down with the help of electricity. And the best example to that is electrolysis of water. Electrolysis of water, one term, and one in case of lesson number 6, that is life process, we are going to read for photolysis of water. 2 terms. Electrolysis that happens in case of when we use this artificial machinery, we supply electricity and the water gets broken down to hydrogen and oxygen. And this photolysis of water takes place during photosynthesis. The plants are synthesizing their food, they break down water molecule. Okay, that is also breaking down water molecule only. As per our textbook, that is activity number 1.7. But in that activity, they have not given the equations. Equations are not mentioned in that. Okay. And here we are going to write down the equations also for that. The second method is decomposition by electricity. Now in that a simple setup we have. Even you can make it at home. Some of the kids they have made and they have brought to the school also. A small plastic mug and you can use 2 iron nails, लोहे की nails लेकर के and there यहाँ से उसको अंदर insert कर देंगे this way and we connect यहाँ जो lower वाला side है that we connect it with the terminal of the battery, one to the positive and other one to the negative. Know that the longer leg indicates positive and the shorter one indicates the negative terminal. That much we know very well. Okay. So if it is a battery, it may have more than one side. It can be this way also, right? And here in this case, you know very well that the terminal that is connected to the positive end of the battery, that is known as. Have we ever come across these terms? Anode and cathode. Yeah. Now in this what happens is that we are supposed to, how you can make this also, it's very simple. A plastic, any of the boxes you can take out a plastic ka dabba, any that bone meter ka dabba and all that also you can take up, cut the half part of it and we can take two nails, iron nails, and make hole on the lower side, and we can insert them, leaving certain gap from where you can connect it with the wire, and the wire can be connected with battery. Then we are supposed to deal with two more test tubes. We can take up two test tubes, fill them with water. Okay, this container also we are supposed to fill up with water first of all. Bring two test tubes filled with water, holding the upper end of the test tube, the mouth of the test tube with your thumb, and then bringing it near to the instrument, you make it upside down. And after leaving it here, slowly you are supposed to leave your thumb. Some amount of water from the test tube will go, but not all. After some time, once these connections are complete and this setup is ready, you will see that the bubbles have started emerging at anode as well as at the cathode. So this is how you are supposed to fix up. And here, all over we have nothing but water. And to make it more conducting, we can add a few drops of dilute acid. That may be dilute HCl or dilute H2SO4, any of those. So water plus a little amount of dilute acid. That may be dilute HCl, dilute H2SO4, either ways. That is actually going to make water more conducting. Now once the process begins, we can see, of course, here also, let's say initially this was the level of the water inside the test tube. Right. Now once the electricity starts flowing through water, we know very well that water is a good conductor, and we have made it even a better conductor by adding a few drops of acid in that. Bubbles will start emerging and rising up. And you will see that the water, which was like almost at the equal level in both the test tubes, in one of the test tubes the water level will be more lower as compared to the other. Actually speaking, we call this process as how these gases are collected. Gases are collected due to downward displacement of water. Downward displacement of water. Now what exactly is that? When the gases will rise up, they will push water down, making space for themselves. I mean, you cannot see the gases there, but you can clearly see after some time that the water level, which was initially somewhere here, will come down a little bit more. And what exactly will be the view? View will be that here at anode, because water is getting split up into two of the gases, right? Water is broken down to two gases, hydrogen and oxygen, we know very well. But initially it is going to get broken down into its corresponding ions, hydrogen ion and oxide ion. So hydrogen ion is H plus, oxide ion is O2 minus. Now common sense, opposites attract. This positive ion is going to go towards which terminal? Negative terminal. And what is the negative terminal here? Cathode. And what is the positive terminal? Anode. So H plus joining with one more H, it will form hydrogen gas, and this will be collected at which terminal? Cathode. Has to be cathode, right? Negative terminal. And O2 minus will join with more oxygen and form O2 gas, oxygen gas, and gets collected at anode. Right? This is the first thing you are supposed to keep in mind. Which gas collects where? That is first important issue in electrolysis of water. And second, in what ratio is it going to get collected? So if you see the water molecule itself, H2O. H2O. This is how much ratio? 2:1. Accordingly, the amount of gases collected also will be the same. The amount of hydrogen gas collected will be double, twice as compared to that of oxygen. So out of these two terminals, if I take this is anode and this one is cathode. Where this hydrogen was getting collected? Cathode, negative terminal. definitely the amount of water pushed down will be double as compared to that in case of oxygen, right? So here one more thing, two things always keep in mind the two. Equation, of course, we are just going to write this here, but remember that in case of electrolysis of water, wherein water gets broken down to hydrogen and oxygen, two important concepts are always asked in exams. The first concept is that which gas collects where, and second, the amount or the ratio of it. So once again, before moving ahead, for the decomposition with the help of sunlight, I want to recall this once again for the last time. Dash gas collects at cathode, hydrogen, and dash gas collects at anode, oxygen. Okay, and which gas will be twice the amount of the first one, hydrogen. Please remember that. Okay, note it down everything because it is not mentioned this way in the book. You need it for writing in your examination. Well, for this whole process, decomposition with the help of electricity, a simple equation, H2O gets broken down to H2 and O2. But this is the story behind from wherein the question comes. Okay, that's the equation for it. Note it down, kids. So at times they may ask you about how much amount is collected, and at times in exam they may ask you that why is it so that hydrogen gas collected is twice as compared to that of oxygen. Then in that case you are supposed to take the formula of water, okay, and start explaining with that in formula itself in H2O, hydrogen is present twice the amount as compared to that of oxygen. So therefore when it breaks down, it is going to give twice amount of hydrogen as compared to that of oxygen. Note it down, kids. Once we have understood this, we will go ahead for the last way of decomposing the compounds. Here in such processes of electrolysis, electrodes, that means here we may take up this as the iron nail, or we may also take up, as mentioned in the book, graphite rod. What is this graphite rod? This gold cell we have, bigger cells are there now. You should break them now. From the middle of it you can get the carbon rod. That carbon rod can also be used. Here in electrolysis of water, anode and cathode, collectively we call them as electrodes. Electrodes are not important, they can both be same. Okay, both may be made up of this iron nail we can take up, both we may take up for graphite rod or this carbon rod. Water few drops of dilute acid, one battery, two wires, and there you are ready for this electrolysis process. And one last thing about this particular reaction. After this reaction completes up, what we may do is that we may keep our once the reaction is over, of course it's hardly 6 volt in this one. We may disconnect also, and then after that we may keep our hands down in the water, bring the test tubes up inside water itself, hold them with the thumb and make them upside down. You understand that? पानी में हाथ डाल के इसी सेटअप में टेस्ट ट्यूब को थोड़ा सा ऊंचा किया, हवा में नहीं आने दिया, पानी में उसके आगे क्या लगा दी, जैसे यहाँ पर ये खत्म हुआ इलेक्ट्रोड यहाँ तक पूरा पानी भरा हुआ है हमारा, इलेक्ट्रोड्स के ऊपर आते ट्यूब्स को, देन यू होल्ड देयर माउथ विद द थंब, पानी के अंदर ही जो भी सामान तो भरा हुआ है, दैट इज द गैस एज वेल एज द वाटर. Okay, that you are tightly closed, and then you make them outside the water, bring them outside the water, and still holding them with the help of the thumb. जैसे ही आप उसको सीधा करेंगे, होगा क्या? Gases lighter है, टेस्ट ट्यूब को सीधा करते क्या होगा? Water will go down, and the gas, whichever gas is collected will come up. Now you can request one of your friends to bring a burning matchstick near to the mouth of it. एक जलती हुई तीली या burning splinter भी सब होते हैं, that you bring to the mouth of the test tube. One of the gases, because it is colorless, you don't know which gas is where. One of the gases will burn with a pop sound. That has to be hydrogen. Identification marker. That it is going to burn with a pop sound. And the other gas is going to make the splinter or the mastic burn more vigorously. That has to be oxygen, because oxygen is a supporter of combustion. Now there is one more question that can be asked: that how will you test the gas is colorless? How will you test which one is hydrogen, which one is oxygen? By burning a matchstick and bringing it near to the mouth of the test tube. These two are there, and for example, in any fine reaction, we have this CO2 with us, carbon dioxide in the test tube. How will you test for that? Again, bring a burning mastic near to the mouth of the test tube. What happens? It stops burning. It is put off. It is extinguished. कोई word हम use कर सकते हैं. But in this question, one more thing. We can add up here itself. Burns with a pop sound. And pop sound, of course, we know. The way you open up these cold drinks, that sound will be there. The moment you remove your thumb and the burning mastic is near to the mouth of the jar, it burns with a pop sound. Okay? When this scene gets normalized, we are going to take it to the lab and we'll show you that this is very much easy to do. And oxygen gas, of course, burns more vigorously. More speed if you write in an exam, that won't be proper. Obviously is okay, that it starts even catching up more fire. Okay, once we have completed this, of course we are going to move ahead with the last way of decomposing the compounds, that is by using sunlight. That is one of the easiest methods. In initial days, what used to happen was that this method was used in photography. But nowadays, of course, we have digital way of taking the pictures, so there is no need for going for negatives and converting them to positives. Have you ever come across those things? Negative, एक कैमरा शॉट में रील चल रहा है, उसका फोटो लिया, negative black color का छोटा सा रील. Have you ever seen that? बड़ी सी होती है in movies. You must have seen that movie roll. कैमरा, पुराने जमाने का कैमरा will be holding that reel. Okay, और रील लगाना है और then of course you can take the snapshots. और फिर उसको आपको बोलते थे negatives को धुलवाने ले जाना है. Means you are supposed to take that reel to the nearby any photo shop that they have, and from there they are going to take out the photographs out of it. So in that they used to use this AgCl, the reaction which we are going to study right now. Okay, decomposition with the help of silver chloride, silver bromide. Both the products are same only. This we have noted down, everybody. Good to go now. So read a bit about it. we are going to deal with the last way of decomposition. Decomposition by sunlight. Its reactions and its processes both are very simple. For example, we are talking about either silver chloride or silver bromide. We are supposed to write down, for example, first reaction you are writing it as silver chloride, and on the arrow mark we write down sunlight. Same way. Second example, if we take up silver bromide, and here again sunlight. So it breaks down into silver and chlorine. This one silver and bromine. Now we need to balance it. Simple way of balancing it again. This is color difference definitely will be there. And why will it be there? That question is also asked in the examinations. These will be the gases state. Black and white golden is once they say that this is a solution is exposed to sunlight, it used to turn grey. अब ग्रे क्या होगा? हमने सिल्वर का कलर देखा है ना, सिल्वर ऑर्नामेंट्स का कलर हमने देखा, सिल्वर का कलर देखा है, वो इट्स लाइक ग्रेइश शाइन होता है उसके अंदर. Initially before the reaction it was there in the form of AgCl or AgBr. जब एक sunlight के form में उसके पास energy आई and the bigger molecule got broken down, the decomposition took place and it got broken down to silver and chlorine or silver or bromine. These are of course gases. Gases you know very well that they're going to leave the system. तो पीछे क्या रह गया हमारे पास में silver. अभी रख रहे हैं, we are keeping a compound and it is turning grey in the presence of sunlight. And why is it turning grey? Because of the formation of silver. Clear? So these small questions they may be asked in this. The equations are very simple for decomposition with sunlight. Okay? Note it down fast. Noted? Fine. Let's go ahead with our next type of reaction. And of course, you can say one of the interesting most reactions, and that is displacement. Okay? Displacement reactions, some example of it in the lower class you have read about. Note it down for 1 minute, kids. 1 minute. Note it. When displacement reactions we are going to, of course, displacement reaction का एक idea दे सकते हैं, but that of course will be dealt in the next class because the time is up. And next session we are going to deal with displacement and double displacement reactions. So read a bit and come prepared tomorrow, right?